When you think about time travel, keep in mind that we are all time travelers. We all have our own personal time machines, and they're like driving a car, except that the car only goes forward, never in reverse. It goes at one speed, it's always stuck in the same gear. You can't turn right or left. And the front windshield is totally blacked out, so you can't see where you're going, you can only see through the rearview mirror. That's the way we travel in time. And what we'd like is to have a car that can go at different speeds and in different directions, forward and reverse, fast and slow. And that's the dream of time travel, and that's, in some sense, what the Stargate is giving us. It's hard for me to imagine when a human being first imagined the possibility of traveling in time. I can picture when an ancient person looked up at a bird and thought, wow, it would be great to fly. Or looked at the moon and said, I wonder if I could get there. But traveling in time is kind of a hard thing to picture. I'm wondering when it first came about that somebody said, I'd like to travel forward in time or travel backwards in time. One of the logical paradoxes in any time travel story is that if you're capable of going back in time and you're capable of doing stuff in that time, you can change the future. And one of the most severe examples of this paradox is called the grandfather paradox. Let's say you go back in time and somehow, accidentally, kill your own grandfather. Well, then you were never born. So where did you come from to be able to go back and kill your grandfather?
Ball must have killed the crew when he gated aboard.
Wow. You're literally a grandfather paradox.
Physicists have thought about this in terms of time travel, and there's two schools of thought. One is that the laws of the universe would actually prevent you from ever killing your grandfather, that somehow the laws of time and time travel don't allow you to interfere with the future. The problem with that is it kind of makes for a boring story. The other possibility is that there are parallel universes, a multiverse, and that when you travel back in time, you're actually arriving in a different time stream. And the things that you do there continue to have effects in that timeline, in that time stream, but not in the one where you started from. In most stories, I think the idea is, well, you can go back in time, you can change things, and if those things are bad, hopefully the heroes can rectify things and put them back on track.
Silk, you have to understand, in the timeline we just came from, the Gould are defeated and the Jafar are free. Now, Ball used a machine to go back in time and change all of that.
And there may be some principles that allow that to happen, and we're just not clever enough yet to know how it can happen.
Until now, other than ancient technology, the only way we know of traveling backward and forward through time is to pass through a wormhole as it intersects the magnetic field of a solar flare.
But, you know, if you have a choice between scientific reality as we understand it today and dramatic license and entertainment in a great story, we go for dramatic license and entertainment every time. The science of time travel, and by extension the science fiction of time travel, is all a question of mathematics. It's all a question of geometry. We can express our universe in space and in time in terms of geometrical mathematical equations. It turns out that there could be other dimensions of space and time in that geometry, and we can express many more dimensions of space and time than you and I can perceive. And we can write that on paper. Even though we're three-dimensional creatures and we're forced to travel in this one-directional time flow, we can understand what it would be like to have more dimensions of space and more dimensions of time. It's only with the onset of Einstein's theories of relativity and quantum physics and so on that scientists began to take the idea of time travel seriously. Maybe it's not just a one-way trip in one direction, but that there are different streams and whirlpools and eddies and bridges and stargates that can take you from one time to another. A stargate is probably some kind of singularity that's been created to make a bridge between two places in space and possibly between two places in time.
The device that made what you see in this picture, an energy vortex created prior to the establishment of a stable wormhole, is called a Stargate. Now, normally we use it to travel to other planets, but this time we came through it from an alternate timeline.
A physicist would call this an Einstein-Rosen bridge. A science fiction writer would call it a wormhole. Now, to be honest, even physicists call them wormholes now. It's much easier to say than Einstein-Rosen bridge. And the idea is that the geometry has been so distorted that it's been reconnected to another place in our three-dimensional space, and maybe another spot in our one-dimensional time. I do have a time machine in the form of a telescope, because when I look up into space with a telescope, and if I'm looking at a galaxy, it's taken several billion years for that light to reach my telescope. And so I'm seeing what the universe was like a few billion years ago. So every time that you look up into space, you are looking back in time. Even just glancing at the sun, you're looking at the sun as it was 8 minutes ago. If the sun were to wink out right now, and I can assure you as an astrophysicist that's not going to happen, but if it did, we wouldn't know about it for 8 minutes. So forget about living every day as if it's your last. Live every 8 minutes as if it's your last. But it turns out that we can actually travel in time thanks to Einstein's theory of special relativity. Einstein pointed out that if you travel faster, your clock will run slower. And we've seen that happen. Astronauts, cosmonauts that are in orbit around the Earth, traveling at, say, 25,000 kilometers per hour. Insignificant fraction of the speed of light, but fast enough that over several weeks in orbit, they're actually aging at a slower rate than you or I here on the Earth by a total of a few nanoseconds, a few billionths of a second. And we can measure those effects. You can put an atomic clock on board a spacecraft in orbit. You can compare it to the ones here on Earth, and you can measure. You can see those differences. Einstein was right about this. And the only difference is that, of course, we haven't been able to travel at close to the speed of light, where this kind of time travel really starts to become noticeable. I think almost every scientist has been influenced by science fiction and fantasy at one point in his or her life. The human imagination comes up with these outlandish ideas, things that seem totally unsupportable by science at the time when they were proposed. One of the beauties of it is that sometimes the science can take it beyond the original idea that seems so outlandish and saying, hey, you didn't even come close to how outrageously bizarre is the universe in which we live. And it's coming full circle. It's like a feedback mechanism is now science fiction writers are taking those ideas out of science and extending them and incorporating them. And that's what you see in a series like Stargate and in the Stargate Continuum movie. And so, yeah, we've become the real estate agents for science fiction authors, in the sense that science informs science fiction informs science, and we're all inspired by it.